All right, today in Algebra 2 here, we are going to be discussing more exponents. And so for 10-2, we're talking about real number exponents, okay? So real number exponents. Now, yesterday we talked about, or on Friday we talked about rational exponents. And today we're going to talk about real number exponents where we actually have, in some of the equations, we're going to have the variable in the exponent. Now, if the variable is in the exponent, it is called an exponential equation, okay? So an exponential equation. So if I gave you, and you should know that, I'll just write it. A good note taker would have already written that down, but exponential equation. What is an exponential equation? An exponential equation is where the variable is in the exponent. The variable's in the exponent. Okay, so an example of that is not y equals x squared, because that's where the variable, you don't need to write this, but that's not a variable, that's not an exponential equation, that's a quadratic equation because the variable's in the base. So that's not it. An example would be like y equals 3 to the x. That is an exponential equation. Now, you might have heard in science class or something like things that grow exponentially. Exponentially means that is growing very rapidly, or it's decaying exponentially. It means it's growing very slowly, or dying or decreasing very rapidly. Excuse me, not slowly. So exponential growth or decay, this is where we start talking about that. You talk about it with your investments or things like that. Now with this, if we did an XYT chart, so go ahead and do a quick XYT chart. We're just going to plug in a few values. Can you plug in negative values? Well, sure. What does the negative on the exponent do? Okay. Well, the negative on the exponent flips it, right? So 3 to the negative 3 would be a small number, 1 over 27. If I had negative 2, it would be 1/9. Negative 1 would be 1 over 3. Can I plug in 0? Anything to the 0 power is? Nice work, Devin. 1. Okay, on top of it today. Plug in 1, we get out 3. Plug in 2, we get out 9. Plug in 3, you get, okay, 27. Now, that graph, just wrote some quick values there. If we did a sketch graph of that, remember, if we plugged in negative 3, so 1, 2, 3, we got out a tiny 1/27. So a small number there. If you plugged in negative 2, you get out a little bit bigger 1/9. If you plugged in negative 1, you get out 1/3. And if you plug in 0, I'll make 1 right there. You get out 1 like that. Now what happens when I plug in 1? Well, when I plug in 1, I jump all the way up to 3, right? Like that. When I plug in 2, I got to jump way up to 9, somewhere up here. So then when I plug in 3, we're way up at 27. So what we see is this graph is going to look like this, and it's going to increase rapidly. So as x increases, as x was 1, 2, 3, this function just rapidly goes way high, right? It goes really high. So that's called exponential growth. It grows rapidly. One thing you ask yourself, will this ever be negative y values? Can I ever get out negative y values? Okay, if you said yes, you're wrong. Don't feel bad. You just, it's a work in progress. If you said no, you were right. You can't get out negative y values because my base is a positive 3, and there's no way to turn this into a negative. If you plug in a negative exponent, remember, it just flips it. It doesn't change the sign of the base. Now, if you have a graphing calculator, you can pull that out. I've already clicked on the y equals function. And no, that bell was not for you if you heard that on the video. Nice try. So 3 to the, okay, so I hit 3 to the x. And I'm going to zoom standard. And we're going to see that graph there like that. Now, I don't know if you can see it very well. Let me just pull it up to the camera here. So that's the graph, the exponential graph, just like I sketched. Okay, so moving on from there, let's go ahead and take a look at some examples, or not some examples, but a couple other things before we do some examples. One thing is that if you have a, excuse me, if you have a negative value, like y, or not a negative value, if you have like a y equals a 1/2 to the x, okay, a fraction to the x, then what's going to happen is you're actually going to have a reverse. It's going to come down like this and look like that instead. So instead of going up like this, it'll come down like that if it's to a fraction. If it's a negative, it just flips it. We'll deal with that later. But these are two basics. If it's a fraction here to an exponent, it comes down and through. Okay. If it's a non-fraction, you just flip it real quick. If it's a base of like 3, non-fraction there, it goes up like that. Okay. Now, the last thing I want to state before we do a few examples is this. Solving exponential equations. Expo equations. Solving exponential equations. There's 3 steps. And your book has them listed on page 460. Okay, step 1, I'm going to say get powers of the same base. And we've actually done these before, and we worked on them on Friday a little bit, not an equation, but dealt with simplifying. If you remember that problem with 8 and 4, we did that. So, and then once we have the powers of the same base, set the exponents equal to each other. And then 3, solve. I guess the book says, check your answer for number 3. It says solve up here, but anyways, that's fine. I won't quiz you on those 3 steps. There will be a problem on the quiz that deals with that, but you won't have to list the 3 steps. So get the powers of the same base, set the exponents equal to each other, and then solve. Okay, let's go ahead and do some examples. And the first one I want to do is simplify. So we're just going to simplify these. Now these are all non-calculator. Okay, so no calculator necessary. One is, what do we have here? If I have 7 to the square root of 3 times 7 to the square root of 2, okay, then what I want to do is I want to multiply these together. Well, can I multiply? Well, the answer is yes, because I have the same base. So 7 and 7 are the same base. So I can say this is 7 to the, okay, when you multiply the same bases together, what do you do with the exponents? You add the exponent. So it's the square root of 3 plus the square root of 2, like that, okay? So it'd be 7 to the square root of 3 plus 7 square root of 2 there. Now, with that, you actually don't change the base at all to say it's 7 times 7 to be 49. You just leave the base, and that would be as far as we go, because we can't combine the square root of 3 and the square root of 2. So you can't go any farther on that. Now, what if I have this one? This is a good little review. 7 to the square root of 3 plus 2. So I'm going to put that plus 2 on the outside. All over 49. Well, again, no calculator. So if I want to simplify this, the issue is I have a 7 and a 49. Well, can I turn 49 into something with a 7? Hopefully you say yes, and it's 7 to the square root of 3 plus 2 divided by 7 squared. Now I have the same base 7 and 7. I can subtract my exponents. So it's 7 to the square root of 3 plus 2 minus 2. And so those 2's will cancel, and you're just left with 7 to the square root of 3. Okay, so powers of the same base, division, so you subtract your exponents, The 2's cancel, you're just left with that. And that's as far as you need to go. You don't need to pull out your calculator and do 7 to the square root of 3. You just leave it like that, okay? What about something like this? Number 3 here. If I have 6 to the square root of 2 times 6 to the square root of 8, we're noticing same bases, so that's a good thing. 6 to the 3 square root of 2. They all have the same basis, so we can deal with them. Don't worry about going 6 cubed and trying to figure out what that is. We're just going to simplify with the idea of the same base. So when you have the same bases being multiplied, what do you do with the exponents? You add them. So square root of 2 plus the square root of 8. Okay? Divided by 6 to the square root of 3. Oh, no, I'm sorry. 3 times the square root of 2. It's 3 times the square root of 2, so 3 times the square root of 2. Now, one thing to consider is, can I change 8, try to combine these at all? Could I do that? Well, sure, 8 is the same thing as what in radical form? I'm going to rewrite the 6 to the square root of 2 plus 2 root 2 over 6 to the 3 root 2. Right? Because 8 is 4 times 2, and the square root of 4 is 2, so 2 root 2. Well, can I add these on top? Well, 1 root 2 plus 2 root 2 gives me a total of 3 root 2 over 6 to the 3 root 2. Oh, same thing over the same thing. That cancels, right? Simplifies to be 1. All right. Good job, Mr. Elson. Nailed that one. All right, let's get to something that would be a little bit more difficult. Which one do I want to do here? Let's do this one. This will be number 4 here. And on number 4, what if I have the square root of 2 minus 1, parentheses, to the 2 plus pi, so 2 plus pi, that's the exponent, divided by square root of 2 minus 1 to the pi. Well, a couple things look different. For starters, I have a binomial here, and then I also have a pi in the exponent. But I can't combine square root of 2 and 1, right? Can't combine those. Think about this. What's this base? Square root of 2 minus 1. What's this base? Square root of 2 minus 1. When you have the same bases, what can you do with the exponent? You can subtract your exponents. So the base is square root of 2 minus 1 to the 2 plus pi minus pi. So therefore my pi's cancel, and I'd be left with the square root of 2 minus 1 squared. Now the common error is to do what here, Khalib? Exactly, distribute the exponent. Don't do it. Can I simplify this though? You bet. It's the square root of 2 minus 1 times the square root of 2 minus 1. You FOIL it together. So you get square root of 2 times square root of 2 is 2. Square root of 2 times the negative 1 is negative root 2. Negative 1 times root 2 is negative root 2. And then a negative 1 times a negative 1 is positive 1. So then I take 2 and 1 and I combine 3 minus 2 root 2. Because negative root 2 minus root 2 is 2 root 2. Okay. Now, right, number 5 here. And number 5 is going to be a solve. And let's go ahead and solve. What if I have 49 to the x minus 2 is equal to 7 times the square root of 7. Now, no calculators required. Okay, what base do you think I'm going to want to end up using? No, Joey, not a base of 17. That was wrong, but it was a good try. We want a base of 7, right? A base of 7. So the issue is I have a base of 7 here. This is a 7, but it's in a radical format. I have a base of 49 here, which I need to change. So 49 turns into 7 squared to the x minus 2. And then let's go ahead and change the square root of 7 into an exponent. The square root of 7 in exponential form is 7 to the, Brendan? No, it's not cross multiplication. No. Okay, there you go. Good redemption. It's 1/2. Okay, I want, again, what I want is a base of 7 over here and a base of 7 over here. Right now I have a base of 7 with a couple exponents, and I have a base of 7 and a base of 7. Let's go ahead and get these exponents combined and then get these bases combined. So an exponent to an exponent, what do? Distribute. So 7 to the 2x minus 4 is equal to 7 to the 1 plus 1/2. Hopefully you're all comfortable with your fractions. It's 3/2. Now that I have a base and a base the exact same, now I set my exponents equal to each other. 2x minus 4 is equal to 3/2. And then I solve from there. I say 2x is equal to 4 over 1 plus 3/2. And a quick fraction, right, is going to be, that's going to be 8 plus 3, so 11/2. 2x is equal to 11/2. And then you would multiply both sides by 1/2 to get 11 over 4. And that's what x is 11 over 4. I'll give you a second to look at that. Any questions? Good. Okay, so then the next one I want to do is, I think you're okay on that. Okay, let's do this one. This one's a good one. Definitely going to be a little bit unique because, I can do it right on the back side here, it is going to be a solving, well yeah, this one's good. 3, what number is this? 6? Okay, number 6. It's going to be a 3 to the 2x minus 6 times 3 to the x plus 9 is equal to 0. Now, this looks really strange, but what I'm going to do is I'm going to manipulate it for you. And just in the interest of time, I'm going to go, I'm not going to ask a lot of questions. I'm going to tell you what to do here. This is the same thing as saying 3 to the x quantity squared minus 6 times 3 to the x plus 9 is equal to 0. I don't know if you can hear that noise out in the hallway on this film, but it is bothersome. Wow. Okay. So anyways, I think it's Cheyenne. Okay. So anyways, what I recognize is that x squared is the same thing as, right, 3 to the x to the second. You multiply that, so 2x is what I'd have there. What I see here is this is the same thing as this. So I'm going to let z equal 3 to the x. Okay, this is our substitution rule. I better box that and keep it separated. So wherever I see a 3 to the x, I'm going to plug in a z. So I get z squared minus 6z plus 9. That's our substitution method. We've done that one before. Now it's in a very workable format of factoring, right? So I get z minus 3, z minus 3, right? Positive 9, right? Negative 3z, negative 3z, negative 6z. Okay, so z is equal to 3 then. Now, I don't want to solve for z. What do I want to solve for? Ultimately, I started with the variable x. So I need to plug back in 3 to the x is equal to 3. Well, if 3 to the x is equal to 3, the exponent on that 3 there is 1, so what do I know? X has to equal 1 in that case. Give you a second to look at that. And Last thing I want to briefly say here is you're going to have to graph some. And so if it said graph these, if you don't have a graphing calculator, that's no problem. You just have to do a quick XYT chart. And so if I had graph like 3y equals 3 to the x minus 2, where that minus 2 is not attached to the exponent. If you don't have a graphing calculator, it's not a problem. Just do an XYT chart. And you start with like, if you plug in a -2, what do you get back out? Now it's fine to use your calculator. You know, you can say 3 to the -2, and you get out 0.111, and you go -2, and you get out a -1.8, or approximately -1.9. When you plug in a -1, you know, 3 to the -1 is going to be 1/3, and then -2, you get out a -1.6. Okay, 3 to the 0 power is 1. 1 minus 2 is -1. You plug in 1. 3 to the 1 is 3. 3 minus 2 is 1. Plug in 2, you get out 7, because 3 squared is 9. 9 minus 2 is 7. Okay, so that's just a quick, you can do a quick sketch of that. And I know I'm rushing, I just want to make sure we get this lecture done. So if you plug in a -2, you're getting out a -1.9. Okay, so somewhere approximately like there. You plug in -1, you get out a -1.6. You plug in 0, you get out a -1. You plug in 1, you get out 1. I'm sorry, you plug in 1, you get out 1. You plug in 2, you get out 3, 2, 3, 4, 5, 6, 7, something like that. So what we see here, and it wasn't the best of graphs like this, but like something like that, coming down like that. Okay? So that's your sketch graph that you can do. If you have a calculator, you can do it on the graphing calculator, or you can go home and plug it into desmos.com and do it on that. Desmos, right? We've done that in class, desmos.com. You can check it out there at home for the 2 problems you have to do. All right, we made it. We'll see you guys tomorrow.